Hey everybody, welcome to the guided problems for chapter 4. I think most of these will be pretty easy for you, especially if you know how to use Excel to do them. So let's just jump into the first one. The table on the right shows the frequencies of executive salary ranges at a particular organization, and then a bunch of questions. So the first thing we're going to do, of course, is open this data in Excel. Just bring this over here. All right. So the first thing it wants to know is how many executives at the organization earn 100,000 or more a year. So you can see this is set up where it's salary ranges and then a frequency and then a total. So really, we know that all of these have to add up to 31. So we're just going to say that this cell equals 31 minus the sum of all of these cells. And it turns out to be 1 in this case. So that was pretty easy because there was only a certain number of, it has to add up to that total. So now it wants the probability of randomly selecting an executive who earned 100,000 or more a year. So we're going to say probability of 100,000 or more. All right, so all we're really doing to find these probabilities is we're saying, okay, out of the 31, what percentage of them made 100,000 or more? So to do that, I would just say this cell equals the number that were 100,000 or more. In this case, it was only 1, divided by the total number of 31. And that's it. It's asked me to round to 3 decimal places. Sometimes to help me keep from making mistakes, I'll just set the decimals to the number I need. So this is 0.032. Or another way we could put that is we have a 3.2% chance of randomly selecting an executive who earns 100,000 or more. All right, the probability of randomly selecting an executive who earned 60,000 or more a year. So we can see by looking at this that this would be all of these people, right? So I'm going to say the probability of 60,000 or more is equal to the sum, the sum of the people that made 60 to 70, 70 to 80, 80 to 90, 90 to 100, or 100 or more. So that's all the people who made 60,000 or more divided by the total. So 83.9%, 0.839. The probability of randomly selecting an executive to earn between 70 and 90,000 per year. So the probability of 70K to 90K. So this will equal the sum of the 70 to 80 and the 80 to 90, right? That's all the people that earn $70,000 to $90,000 divided by the total. All right, so now we're on to the next question. So this one says, use the contingency table to complete parts A through D below. So I'm going to open this in Excel. All right, so there's our contingency table. To make this a little easier on myself, I'm going to put some total columns and a total row in and total these up. Now I have the totals of each row and the totals of each column. And we see that we have 100 total events happening. So it wants us to do the probability of A given C. So probability of A given C. All right, so the way you have to think about this is if we say the probability of A given C, what we mean is if we're only looking at event C, that's what given C means. What's the probability that A occurred? So if we're only looking at event C, there were 24 possible outcomes, and A was 8 of those 24. So the probability of A given C is 8 divided by 24. 0.333. This one wants 2 decimal places. So 0.33. All right, the next one is the probability of C given A. So we're going to say now the given is A. So we're only considering items from column A. So the probability of C given A would be 8 out of the total of 49. The probability of C given A is going to equal C out of the total of 49 for all of A. Probability of B given E. You don't have to highlight it like this. This is just me trying to make it a little easier for you to see. So given E, meaning we're just going to look at E, what's the probability of B given that? So it's going to be 28 out of the total of 57 for E. The probability B given E is going to equal 28 divided by 57.49. All right, one more. The probability of E given B. So given B, I won't highlight it this time. I'll just do it like that. What's the probability of E given B? So we're going to say this equals the probability of E, 28, out of all of the B's possible, 51.55. There we go. So that was question number 2. Let's move on to the next one. All right. So now it's asking us the order of objects is of importance. So these questions are about permutations or combinations. And the first thing you have to figure out is, am I doing a permutation or a combination? Permutations are when the order of the objects that we're dealing with are important. It matters what order they're in. That limits us a little bit from a combination when order doesn't matter. So that's kind of the key word to look for, is if objects are important, or the order of the objects, I'm sorry, is important, that's a permutation. And if it's not important, that's a combination. So once we know if we're doing a permutation or a combination, it's pretty easy because we just do equals permut for permutation. And then it wants the number. So there's 11 objects, that's the number, comma, the number chosen, and this is selected 2 at a time. So in other words, if we have 11 objects and we're going to pull 2 out of there, how many different ways can we do that if the order matters? And there it is. So it's 110. All right. In a race with 8 swimmers, how many different orders of finish are possible for the first 3 positions? So this is a similar question, but with, I guess, more context, more real life scenario or whatever. So again, we have to ask ourselves, does order matter? And this one, it doesn't tell us, right? And the last one, it said, well, order matters. Here you have to figure it out. So the question is there a difference in racing between first place and second place and third place? And the answer is absolutely. You know, we recognize that order matters. And so these are a little bit harder because you have to kind of think of the logic of it. So again, because order matters, we'll be using permutations, equals permut. And then the number, there's 8 different swimmers in the race. And we're looking at the top 3, so 3 people chosen. And there are 336 possible permutations of that. And that's it. So hopefully that one was pretty easy for you and went pretty quick. And I hope it helps you with the rest of the homework.